The overall goal of this procedure is to perform hind limb unloading, or HU, in mice with a simpler, more straightforward method that minimizes stress for the animal. This tail ring method successfully induces hind limb atrophy without compromising overall health and body weight. The first step is to implant a tail ring into an adult mouse. It is important that body weight and health observations are recorded throughout the study. The hind limb unloading apparatus is then assembled and placed into a cage where the unloading will take place. Once the animal has recovered, it is placed in the apparatus for the unloading procedure. Ultimately, results can be obtained through measurements of both body and muscle mass that show muscular atrophy in the hind limbs of unloaded mice.
The main advantage of this technique over the existing methods, like the Morey-Holton taping technique, are that the skin of the tail is always visible, mice are not able to get out of the suspension apparatus or play with the ring, and are quicker to recover and maintain a stable body weight.
This method can help answer key questions in the musculoskeletal physiology fields, also in gravitational and space biology, such as how to prevent skeletal muscle atrophy and bone loss after prolonged periods of physical inactivity, bed rest, limb immobilization, microgravity, neuromuscular disease, and with advancing age.
We first had this idea when we experienced complications with the Morey-Holton tail taping technique. We consistently lost animals and experimental data due to mice escaping from the hind limb apparatus.
Demonstrating this technique today are Andres Ferreira, Senior Research Associate from my laboratory, and assisting Andres is Jacqueline Chrissy, a doctoral student in the lab, and Andrew Dunn, an undergraduate student also in the lab.
Begin by sterilizing the surgical area. Anesthetize an adult mouse with isoflurane, and then record the weight of the mouse and place it on a heating pad. Prepare the tail for surgery by scrubbing with chlorhexidine solution. Start counting from the end of the body hair at the base of the tail to locate the 5th, 6th or 7th intervertebral space between two bony bumps on the tail. Use a hemostat and a 25G needle to make a pilot hole between two vertebrae into the intervertebral space. Remove the needle and insert a steel suture cut to a 10 cm length through the hole. 5 cm of suture should protrude from either side of the tail. Place the tip of your thumb onto the tail and use your free hand to wind the steel suture around your thumb. Twist the ends to form a big loop. The wound or circular part should be plus or minus 3 mm long. Clamp one strand of suture with the hemostat and bend it into a smaller loop, the end of which is attached as closely as possible to the twist on the original large loop. Cut off excess wire and bend the twisted wire back. Stop any excess bleeding with silver nitrate sticks. Allow the animal to recover for 5 to 7 days prior to hind limb unloading, or HU. After surgery, the mice are housed singly to prevent the tail rings from getting entangled. Lay a 1 inch wide by 3/8 thick plated slotted steel bar over the top of the cage and tape it down. Add another washer and wing nut, but do not fully tighten them to allow for adjustments to be made later. Insert the machine screw through the center hole of the bobbin. To prevent the bobbin from falling off, screw a nylon lock nut to the end of the machine screw. The bobbin should swivel freely. Insert the snap hook from a fishing swivel through the lower part of the bobbin. Use pliers to form an S-shaped hook from a paperclip. Insert one end of the S-shaped hook through the hole of the fishing swivel and pinch it shut with the pliers. Place a U-shaped wire parallel to the machine screw on the inside of the cage and bend the ends over the side to support a full water bottle. Insert a water bottle into the U-shaped wire with a spigot facing down, but not touching the bottom. Secure the water bottle to the cage with duct tape. Bend a 2-inch binder clamp open, leaving enough tension to hold a few pieces of food without crushing the pellets. Prior to the hind limb unloading procedure, record the weight of the mouse to use for comparisons later. Insert the open end of the S-shaped hook through the smaller ring protruding from the tail. Adjust the height of the mouse by tightening or loosening the lower wing nut on the machine screw. The lower extremities should not be weight-bearing. Once the optimal height is achieved, tighten the upper wing nut. Reposition the water bottle and U-shaped wire so that the mouse cannot climb onto the spigot with its hind limbs. To measure food consumption during the study, weigh pellets prior to placing them into the binder clamp. Provide about 8 to 10 grams to allow for the consumption of about 5 to 6 grams of chow per day per mouse. Position the binder clamp with food on the bottom of the cage so that the mouse cannot climb onto it, and tape it down with duct tape. Using 2 by 2 inch gauze, loosely wrap the tail onto the fish swivel. Wrap a small piece of tail around the gauze, securing the gauze to the tail. This step is important to prevent the tail from drooping downward, leading to blood pooling in the tip and the tail becoming necrotic. Repeat the same procedure for an additional animal on the other side of the cage. When housing 2 animals per cage, space them so that they can almost touch each other in the middle of the cage. Add a small amount of cob bedding to the cage, making sure that there is not enough for the mouse to use to form a mound. After the hind limb unloading procedure, remove the animal from the apparatus and remove the tail ring using a wire cutter. Record the body weight and return the animal to its home cage for recovery. After a period of recovery, the animal is weighed again and the soleus muscle and adrenal masses are measured. Body weights prior to the tail ring surgery were not significantly different from those 5 days after surgery and prior to HU. Although hind limb unloading for 14 and 28 days resulted in a small but non-significant loss in body mass, the mice fully recovered to their pre-HU body weights after 3 days of recovery. Food consumption for ambulatory control mice and HU mice is shown here. Average daily food intake was not different in HU mice over 28 days compared to controls. Significant soleus muscle atrophy is observed following HU for 14 and 28 days, indicating an effective procedure. After 3 days of recovery, soleus mass was significantly greater than both of the HU groups, but still significantly less than ambulatory control animals. Both the left and right adrenal glands were excised and weighed to provide an indicator of animal stress. As seen here, the average weights were comparable between control and HU mice.
Once mastered, the tailoring surgery can be completed within 5 to 10 minutes per mouse, and the cage setup can be completed in 15 minutes.
Following this procedure, other methods like mice hind limb reloading and recovery from disuse atrophy may be performed in order to answer additional questions such as how the muscle and bone systems can recover and respond to these prolonged periods of disuse.
Now that you've seen this video, you should have a good understanding of how to perform hind limb unloading in mice. This technique permits the study of multiple tissues and systems, such as cardiovascular, musculoskeletal, and integument, under loading and reloading conditions, and using a variety of mouse models, such as knockouts or knock-ins.